Alright, hey, what's up everybody? Let me go ahead and wave to you guys in a degree 10 polynomial, or a degree 10 polynomial with a negative leading coefficient. Alright, so, haha. Anyway, so, I'll start off with my joke of the day, and that's this. Okay, so, to do this joke, the first thing you have to know is this. So, pi times diameter equals c, that's for a circle, right? Or in other words, 2 pi r is equal to the circumference, or pi d is equal to the circumference. Okay, so the joke goes, what happens when you divide a pumpkin's circumference by the diameter? In other words, c over d is equal to pi. So what happens when you divide a pumpkin's circumference divided by diameter? Well, you get pumpkin pie, right? You get it? Alright, so anyways, it's a little more intensive than I thought it would be. So, pumpkin pie. Alright, so today we're only going to do one of them, only one problem for Chan Academy, and it's mainly because these take like a little time to explain, and I want to just take the time to really do a good job of it. So let's go ahead and start with this one, and this is the example I want to do. 3x plus 1, and I have 3x cubed minus 5x squared plus 10x minus 3. In other words, this is really this. It's the same thing as, 3x to the third power minus 5x plus 10x minus 3. And it's all over 3x minus 1. So what we're trying to do is we're trying to simplify. Like, in other words, if we had 8 over 2, that becomes something like 4, right? This should also simplify. The bottom is going to disappear and the top is going to give us something. Alright, so I'll delete all that up. Okay. So the first thing I see here is I want to get rid of the left column. Just like in a basic long division problem, I would have something like 17 and divided by 235, right? Now, I'm going to actually leave this on the side here. So let's do this. 17, right? And I want it to get into 2, but that doesn't work, so that gives me a 0. And then I say, okay, let's try 17 and 23. Okay, well that goes into it once. So I have to subtract off 17. And that gives me 6. Right? And I'll switch over to green. Alright, so now we're going to figure out, does 17 go into 6? No, so I have to drop down to 5. How many times does 17 go into 65? 17 goes into 65, 34, 41, 51. So 3 times. 51. So you subtract off 51. I noticed that you're always subtracting off, right? 17 once. So 51, that leaves me with 14. Okay. So I'm left with 13, and my remainder is 14 over 17. So my complete answer should be 17, should be 13 and 14 over 17. Okay, so it's 13 and 14 over 17. Okay, so I'm going to leave this here. Hopefully that won't screw me over later, because I might need more room, but let's see how this goes. Okay, so I'm going to start off over here. I see 3x plus 1, and I want to get rid of the leftmost column. So 3x to the third power. How can I get this 3x to match up to be 3x to the third power? Well, I think I want to match the degrees, so I would want to get x to the third power. Okay, so I need to multiply by x squared to get it to the third power. If I multiply by x squared, remember, just like in this example, I have to subtract. So I'm going to subtract x squared into here should be 3x to the third, and then plus 1. 1 times x squared gives me x squared. Okay. So from here, I should have, well, this cancels out and it gives me 0, right? 3x to the third minus 3x cubed. Then I have minus 5x minus x squared. So minus 5x squared minus x squared, that should give me negative 6x squared. And just like in the other example, we pulled down the next side. So we're going to pull this down. Plus 10x. Okay, so now I'm going to switch my color to blue. Okay, so I want to get this 3x plus 1 into this one, 6x squared plus 10x. Now how can I get 3x plus 1, and I'm focusing on the 3x here, to get rid of this negative 6x squared? I always want to get rid of the leftmost stuff, right? Just like in this example, I want to get rid of this 3x squared. Now I want to get rid of this negative 6x squared. Okay, so 3x squared, how many times does that go into negative 6x squared? I want to get 3 to negative 6, so I want to do negative 2. Okay, and I also want to do an x, because I want this to be x squared. Okay, now this is the tricky part, right? Because this is a minus, right? So in this case, instead of adding, and it's kind of counterintuitive right now, you're really making it, well, let's see what happens. We can think of it 2 ways, and I'm going to stick to this way. So I'm going to stick to this way. So we're going to do minus, and I have to figure out what goes inside. What goes inside? Negative 2x times 3x, that gives me negative 6x squared. Okay, and that's squared, it looks weird. And then negative 2x times 1 gives me minus 2x. Good. Now all I need to do is finish this up. Negative 6x squared minus minus 6x squared. Remember, minus minus becomes a plus. So negative 6x squared plus 6x squared, it gives me 0. Good. Positive 10x minus negative 2x. Okay, that should be plus 2x then. So positive 12x. Great. And the last thing I'm going to do is I'm going to bring this one down. Minus 3. Just like how I brought things down in this case, right? Okay, so now I just need to figure out how many times does 3x plus 1 go into this thing. 3x into 12x. That's what I want to do. And I'll switch over to green. So now I'm on my green step, and I want to get rid of this guy. Alright, so how many times does 3x go into 12x? Well, it should go in 4 times. And I would say that's positive 4 times. Okay. So from here, I am going to multiply. But I'm going to write my subtraction symbol first. 4 times 3x gives me 12x. And then 4 times positive 1 gives me positive 4. Okay, so from here, I'm pretty much done. Let's see what happens. 12x minus 12x gives me 0. Negative 3 plus 4 gives me, or negative 3 minus 4 gives me negative 7. Okay, so we're left with the remainder of negative 7. There's no way 3x minus, or 3x plus 1 will ever end up fitting up into negative 7, right? So we have this, and we have a remainder of, let me go ahead and color code this guy into, let's do purple. Alright, I'm going to take this guy, and I'm going to leave him up here. So minus 7, but since it's a remainder, recognize that it's still being divided by 3x plus 1. In the same way that this one had a remainder of 14, and that became 14 over 17 because of this 17, right? The 14 is still being divided by 17. So we have this negative 7 here, and it's still being divided by 3x plus 1. Okay, so in other words, this is kind of like our remainder sort of thing. It's like this fraction right here. So you take each piece, you keep getting rid of the left column, you'll be left with something, maybe sometimes, where you take the remainder over something, when that something's always this thing. Okay, alright. So I know this division stuff is kind of, it's hard to get used to, but I think if we just practice and practice and practice, we'll get pretty good at it. So let's work on it some more in class. I'll see you guys, and then it'll be color day soon enough. So I will see you guys in class.